Welcome to the R section of our alphabetical order of the civilized variations of the Fire Dojo. And we're on the rig drill, okay? And so here's the real variations with this method, because we're just playing around. Right? The what if question. What if? What if I could? What if we could? What if we could create something where the pressure was not supplied by a pressure brace? Okay. What if it's a unilateral pressure force, a unilateral force supplied by a cordage, but I guess it could be a bilateral force too. But we're doing a unilateral force. So unilateral force, but the pressure cannot be supplied by a pressure brace. How do you do that? So my idea was to make the spindle heavy enough to provide the pressure. So these are steel tubes. This one is 1 inch, and this one is 2 inch diameter internally. And so the idea is to have the weight of these, and they're 4 feet long. The idea is the weight of the spindle alone is the pressure supplied by gravity. So there isn't necessarily another external force pushing down, but gravity alone on the spindle is enough pressure to create the coal, to create the friction. So how do I do that? Well, I guess we're going to find out. So my idea for how this is set up, the reason why, first of all, its name, the rig drill, is because when I first envisioned this, I imagined an oil rig, like a very tall pyramid-like structure. If you think of a classic oil rig, with a drill in the center. So what this method needs is a exoskeleton. Okay, so I was going to make this pretty, tall, oil-rigged, pyramid-like structure, but then I realized that, well, I have an exoskeleton already. I have the Fire Dojo framework. All right. So the other thing that I pictured was something that looked very Metropolis. Metropolis is an old silent German movie from the 1920s, which is pretty famous actually, and it's been there's clips of it in certain music videos and things like that, and it's in your mind. It's like the picture of a guy who's like working machinery with large levers, things of that nature. So it kind of has that look to it. This is what I pictured. So gonna throw this thing together for you so you see how it works, and let's see if my theory on whether gravity alone on a heavy enough spindle is enough. And so the other question is, since it's not bipolar with a pressure brace, how do you keep the axis with the unilateral force going back and forth? How does that happen? Well, let's see if I balance all the variables. All right, here we go. Alright, so here we are with the rig drill. And as my daughter is on the side eating brownies. So we're all set up. The base is stabilized in place. I have the lever, actually, so this steel pole, this tube, I found out weighs 6.6 pounds. And how I figure that out is my daughter weighs 48.8, and because the steel bar wouldn't register on the scale. So I put my daughter on the scale, she's 48.8 pounds, and then I put her on the scale with the steel tube, and then I minused the weight, and it turned out to be 6.6 pounds. The other bar is, what was it? It's just over 10 pounds. But when we do that, I'll get that exact measurement. So the lever is an ash handle from the hardware store. And as you can see, it's hinged together and hinged to the table. Okay, it's marked for the center of the table as a fulcrum. And the pulleys work extremely well. I got the tension just right. As you can see, it's wrapped around several times, and it's secured to the handle. Now, what we have here, as I did a couple test runs, I have Douglas fir on Douglas fir as spindle reload and reloading base. So I'm going to put this on the stand. Give you an idea how this works. Again, this is kind of the Metropolis film kind of look. So we have this lever, and it goes back and forth. Okay. Oh, I forgot to show you the how we control the space. Let's go back and do that. So up here, I have a section of PVC that's clamped in and screwed to the top beam of the fire dojo. And the fire dojo is an exoskeleton for this thing. Now, as you can see, there's some space in there for it to groove, but the space is contained. It's controlled space. So technically it's not bipolar. I have controlled the space around the spindle, is what I have done. Okay. Now, here's how this looks. So, since I have the resistance up here, and I'm holding down here, and the fulcrum is here, that means that this is a class 3 lever, right? FRE 1, 2, 3. So E, what's in the middle, is the effort. So the effort is in the middle, and the resistance and the fulcrum are on the ends. So this is a class 3. In this instance, it could be a class 2, where I do this, but it's designed so that as I stand here, my hands go naturally at my shoulder height, and I just move it back and forth. And plus, since the rope is up here, I maximize the angle to get as much rotation as I can. Okay. So what I can feel automatically is the weight of the steel tube is not enough for Douglas fir. So what I'm going to do is I'm quickly going to replace the Douglas fir core 2 with something lighter, probably some sodal. And so I'm going to do that real quick and see if 6.6 pounds as a steel tube will work. If not, I have to figure out a way to increase the weight of the spindle. All right? Be right back. Okay, so we're back, and I made a brand new Core 2 of Sodal, spindle reload, and a reloading base, base reload. And here's an example of that Sodal here. Okay. So here's what we know. As I move this back and forth, I can tell that 6.6 pounds is even still not enough weight for something even lower dense, like Sodal. And this is old Sodal too, so it's even less dense than just freshly cut Sodal and put away. So 6.6 pounds is too light for this. And on top of that, this is exactly 1 inch diameter surface area without taking out the dead space center. So I have to figure out a way to balance out the fact that I need more weight on the spindle for gravity to be able to do its job. All right, so I'm going to try and balance that out. Come right back. Okay, so we're ready to try again. And so what I've done is I've cut one of the wings off of one of the 3-inch PVC brace, and what I did was I figure I could use this part here to control the space around the 1-foot galvanized nail. So I epoxied a galvanized nail inside the 1-inch pipe. First I put a ball of napkin down inside all the way to the screws, and then I filled that with epoxy. Then I put the nail in, and then I just kept filling it with epoxy till it went all the way to the top. So now, as you can see, I have it braced this way with the nail to keep the axis nice and straight and control the space as best as possible. I have the Douglas fir in there. So I think we're ready to give it a shot. Alright, so let me get over there, I'll be right back. Alright. So here's how this looks. So we have about almost 17 pounds, basically. It's got a bit of a vibration still. We're starting to get a little smoke, some more dust. We work out class 3 lever. Well, that's definitely mated, although the hole is a little large. It's starting to oval out again. So I'm going to do a close-up of it a little bit so you can see. So I'm going to try and tighten that up a little bit. I'm going to put a notch in, and we'll see how we do. Okay? Be right back. Okay, so I've made a new reloading base of Atlantic white cedar, and I kept the Sodal spindle reload. I filled the notch, so I mated it a little bit. I filled the notch with some sawdust, and we're ready to give this a shot. Okay. Warmed up. Again, we're working with about 17 pounds. This dust looks a little darker. You can smell the cedar mixed with the Sodal smoke. We go a little faster. Get a good rhythm. It's still bouncing around a lot. Getting a lot of friction. Go for a little bit more speed. And we have a coal. All right, success. And there it is. The first gravity spindle. So 17 pounds, approximately 17 pounds of spindle. No pressure brace, just controlling the space up top, trying to control the axis a little bit. Let's narrow in on that a little bit. Nice big fat coal. So I would definitely clean up the axis a little bit as best I could in the future. But it did its job, holding it in place, that nail. Alright, on to, well actually, I don't need to do an epimethii. So here it is, the gravity spindle. Friction fire done completely without a external pressure brace. Alright. So the next thing on our list is S, the seesaw drill. And I predict that's going to be a very quick section because we went over the ore drill previously, which is the sister of the seesaw drill. Alright, so S for saw next. Alright, let's keep going.